a conducting wire. Suppose we have two capacitors. ठीक है, हमारे पास दो capacitors हैं. Capacitance of this capacitor is C1 and capacitance of second capacitor is C2, and they are connected. They are connected through a conducting wire. Then charge flows from the capacitor which is at higher potential to the capacitor which is at lower potential. So initially these two capacitors were at different potential. So let's say that C1 was at potential V1 and C2 was at potential V2. So after connecting these two capacitors through a conducting wire, charge will flow from a capacitance at a capacitor at higher potential to a capacitor at lower potential. कब तक flow करेगा charge? जब तक दोनों का potential same ना हो जाए. ठीक है? कब तक flow करेगा? This flow continues till the potential becomes equal. Okay, till the potential becomes equal. So what is the charge? How do we relate capacitance, potential difference and charge? Charge is capacitance. Charge is equal to capacitance into potential difference. ये होता है relation. So for this capacitor, what is the charge? C1 V1 is the charge carried by this capacitor, and C2 V2 is the charge carried by second capacitor. Now we have connected these two capacitors through a conducting wire. Now charge will flow from the capacitor which is at higher potential to the capacitor which is at lower potential. So what is the total charge before sharing? Total charge before sharing. Initially, if we consider these two capacitors disconnected, then total charge on capacitor 1 is C1 V1 plus charge on capacitor 2 is C2 V2. But once they are connected through a conducting wire, then charge will flow from one capacitor to another till the potential becomes same. So after this connection, both acquire the same potential. Both the capacitors will acquire the same potential. Now what is the total charge after sharing? Total charge after sharing is C1V plus C2. Total charge before sharing is C1V1 plus C2V2, while total charge after sharing is C1V plus C2V2V. This is total charge after sharing. So we can write this as, we can take V outside and we can write this as C1 plus C2 into V. Because we know that charge is a conservative quantity. It is conserved. Charge is always conserved. It can neither be created nor be destroyed. है ना? It is only transferred. What does it mean? If we apply this thing here, what does it mean? It means that total charge before sharing is equal to total charge after sharing. Yes? Total charge after sharing is equal to total charge before sharing. So from here we'll get total charge after sharing is this C1 plus C2 into V, and total charge after sharing is C1 V1 plus C2 V2. From here we can get the expression for common potential. It's C1 V1 plus C2 V2 upon C1 plus C2. This is a final expression. देखो loss of energy on sharing charges. Loss of energy on sharing charges में क्या है? Consider two capacitor, one with capacitance C1 and it is at potential V1, and second one is at capacitance of capacitance C2 and it is at potential V2. Okay, so loss of energy on sharing charges means we have these two capacitors. They are of different capacitance and they are at different potentials. Okay, so they'll have different charges because they have different value of C1 and V1. So they'll have different value of charges. So charge on this capacitor is C1, V1 and charge on this capacitor is C2, V2. So let Q1 be the charge on this capacitor and Q2 be the charge on the second capacitor. So this is before sharing. So once they are connected, once these two capacitors are connected through a conducting wire, then charge will flow from a capacitor which is at higher potential to a capacitor which is at lower potential till the charge on both the charge will flow from a capacitor of higher to lower till the potential on both the capacitors become equal. So we can consider common potential as B. Okay, because you can see that here there is a flow of charge. Flow of charge will take place, है ना? यहाँ पे charge flow होगा ना? And this charge will flow from a capacitor which is at higher potential to a capacitor which is at lower potential. Okay, so there is always loss of energy in sharing charges. There occurs energy is dissipated in the form of heat or some other form of energy. ठीक है ना? चार्जेस मूव करेंगे तो उनको काइनेटिक एनर्जी भी चाहिए. जब कोलाइड करेंगे तो हीट एनर्जी प्रोड्यूस होगी कोलिजन से. रेजिस्टिव फोर्सेस विल एक्ट ऑन दिस, है ना? Because of the material of the conductor, there are certain resistive forces and some energy is dissipated in overcoming those resistive forces as well. And some energy is dissipated while the charges move, they also they may collide, है ना? So when they collide, then some energy is dissipated in collision. As heat produce हो सकता है, कुछ भी हो सकता है. So there is loss of energy. So if we talk about energy, then what is the initial energy? Initially, this capacitor has energy of half C1 V1 square. We can say it's E1. And this capacitor has energy half C2 V2 square. But once they are connected, they both are at same potential. है ना? Then what is the charge? What is total charge on them? It's C1 plus C2V. This is how we write. This is how we write. Yes. And what is energy? Half. Yes. Half C1 plus C2 into V square. So this thing is before sharing. We had this. And this is after sharing. Okay. Now we will find loss of energy on sharing charges. There is energy, some energy is lost. So loss of energy. How do we find loss of energy? Loss of energy means which energy is greater? Initially, the energy we had or final energy? Which is greater? Initially. Initially, energy was greater, right? So if you have to find loss of energy, how do we write? What should I write? Initial, we'll do initial minus final. So initial energy is E1 plus E2. And final energy is E. Greater minus smaller करेंगे. So initial is E1 plus E2. This is the energy stored in capacitor of capacitance C1. So we can write half C1 V1 square for this. And this is the energy stored in capacitor of capacitance C2. So this is half C2 V2 square. And minus E. E is this energy. After sharing, when charge flows from one capacitor to another and both the capacitors require the same potential, then energy stored in the combination, in this combination, is the final energy. It is minus half C1 plus C2 V square. This is how we write. Okay. Now what? Let's solve this. Half C1 V1 square plus half C2 V2 square minus half C1 plus C2. We know the expression for common potential. Common potential is, how do we write? We simply equate this Q as Q1 plus Q2. This is how we write. And Q is total charge after sharing. And Q1 plus Q2 is total charge before sharing. Charge is conserved. So they are equal. So we can, for this, we can write C1 plus C2V, and this is C1 V1 plus C2 V2. So common potential is C1 V1 plus C2 V2 upon C1 plus C2. So we are going to put this value here for V square. Okay. So we'll get C1 V1 plus C2 V2 upon C1 plus C2 square. So next we can write half C1 V1 square plus half C2 V2 square minus half. It's C1 V1 plus C2 V2 square. In the denominator, we'll have C1 plus C2, because you can see that here we have C1 plus C2 and here also we have C1 plus C2 square. We can cancel this. One C1 plus C1 plus C2 will be cancelled. And we are left with only one. Okay, easy. Now, what should I write? We can take 2C1 plus C2 as the denominator. In the numerator, we'll have C1 V1 square. In the bracket, we can write C1 plus C2 plus C2 V2 square. Again, in the bracket, we can write C1 plus C2 minus, no need to write C1 plus C2. We'll simply write C1 V1 plus C2 V2 whole square. Yes? Done. On solving this, you will get C1 C2. In the bracket, you will have V1 square plus V2 square minus 2V1 V2. In the denominator, we can write 2C1 plus C2. Or this can be written as C1 C2 V1 minus V2, because this is A square plus B square minus 2AB. No? So we can write A minus B whole square on 2C1 plus C. See, this value is positive. V1 minus V2 whole square. Whatever we have in the bracket, when we square it, we get a positive number. Yes, this value is positive. Therefore, loss of energy is positive. And this loss of energy appears in the form of sparking or heat produced. This loss of energy appears in the form of sparking or heat. Okay, as we had discussed ना, लॉस ऑफ एनर्जी कैसे होता है? एनर्जी डिसिपेट होगा किस फॉर्म में? कोलिजन से हीट प्रोड्यूस हो सकता है, रेजिस्टिव फोर्सेस में एक्ट, बिकॉज कंडक्टर का अपना एक मटेरियल होता है, उसकी अपनी रेजिस्टिव प्रॉपर्टीज हैं, इट हैज इट्स ओन रेजिस्टिविटी, it has its own resistive properties. There are certain kind of, there may be certain kind of resistive forces, there might be dissipative forces, any kind of dissipative forces, जिसकी वजह से जो लॉस ऑफ एनर्जी है वो होगा जब चार्जेस फ्लो करते हैं. ठीक है, और वो जो फ्लो लॉस है वो किस फॉर्म में अपेयर हो सकता है, स्पार्किंग के फॉर्म में या फिर हीट के फॉर्म। ठीक है।